Okay, so we are on page 230. You'll notice on page 230 there is a picture of a candle with a match. I have a candle and a lighter, and I also have a glass. And you can probably imagine what I'm going to do with the glass. But we're going to have a little demonstration here, and I hope to try to do some high-speed photography here. We'll see what happens. So, what chemical reactions are involved when you strike a match? What further reactions happen when the match is brought close to the candle and the wax burns? Is it nice and cold? Okay, that's good. Just keep it separate from that one, that's all. Yeah. I guess I'll know which one is cold, right? Okay. Chemists use their knowledge of types of reactions to decide on the chemical composition of matches and to explain how these chemicals react in Figure 1. There are different categories of chemical reactions, which we're now going to be looking at. One possible category is called combustion, and combustion is the very rapid reaction of a substance with oxygen to produce compounds called oxides. We often call this process burning. One way to represent combustion is using the following word equation. Fuel plus oxygen gives you oxides plus energy. And where do we burn things? Like, why do we burn things?
Stay warm.
To stay warm, because we want the heat, maybe to cook something, right? Maybe you're making s'mores or something like that, right? Stay warm. Exactly. Okay, so combustion is a rapid reaction of a substance with oxygen to produce oxides. Usually there is a release of energy, and that energy is usually in the form of light and heat. Okay? If that's what you need to do. Exactly. Now, sometimes things combust much more rapidly than others, right? Can you give me an example of something that combusts quickly? Gasoline. We use that in our cars, right? Mosquito spray? Really? I didn't know that. Okay. Coffee mate too. Did you know that? Yeah. Didn't hear it from me. Can you give me an example of something that combusts more slowly?
A dead body.
I'm a little bit nervous about that topic there, Cole. Wood generally doesn't combust very quick, right? Okay, so it's a rapid reaction of a substance with oxygen to produce oxides. Usually if there's a release of energy. Generally it's some fuel plus oxygen. Where does the oxygen come from? The air.
Trees.
Produces oxides plus energy. Heat and light. Okay, so I'm just going to put the recording here on pause. The skeleton equation for the candle is going to be, what's the wax? C20 H42 plus oxygen, which is O2, and it produces carbon dioxide, which is going to be CO2 plus water, which of course is H2O. And we saw that when it condensed on the glass. Okay. Where does the oxygen come from?
The air.
The atmosphere, the air. Right? Where does the carbon dioxide and the water go? Into the atmosphere or air. Right? Write a balanced equation for this reaction. Can we balance this? This one's going to be tough. I'm going to give you 2 minutes while I mark my attendance for you to try it. Because obviously, how many H's have I got over here? 42. We're going to have larger numbers in here, right? I'd like you to try that balancing. Go. All right, well, let's count. How many C's on the left? 20. How many C's on the right? Oh, only one. That's not good, is it? How many H's on the left? 42. How many H's on the right? 2. Okay. And how many O's on the left? 2. And how many O's on the right? 3. Oh, this is going to be ugly, isn't it? Where should I start, do you think?
Big one.
The big one? Should I make the H42? You want to do that? Okay. I really have no idea where to start. Let's try it. So you think I should make the H42, so to do that I would need a what there, Mike? What do I have to put here to make 42? Okay? 40? 21, is it not? What's 21 times 2? 42, right? Okay, so I put my 21 there. Now I've got 21 O's plus 2 O's, now I got 23 O's. Okay, well, we'll see what happens here. Let's balance the carbons. What do I have to do to this one to make the carbons balance? Leighton, what do I do to make the carbons balance here? Got 20 carbons here.
So 20 on there.
Put a 20 on there. Okay, that makes that 20. And what does that do to my O's now, Leighton? 22's is
43.
That's 40 plus 21. Graham, what's 20 plus, what's 40 plus 21? 61. That's 61 O's.
There we go.
Oh, my H's, how are my H's? I forgot to do that one, right? 42. My H's are good, my C's are good, the only thing that's wrong is my O's. How am I going to make 21 O's over here? 61, I got to make 61 O's. What am I going to do? Times it. 30, oh, that's why you want to do the half, was it?
Yeah.
Well, that would be... Cole says do that, go 30 and a half. I might have an idea here. If it's 30 and a half, what if I took everything and did what?
Are you making new rules?
I am making new rules here. What if I took everything and multiplied everything by 2? Would that make everything nice?
Yeah.
Would that work? Like what if I just multiply it? Says let's just put 2 times everything. I'm going to put a 2 in front of this. I'm going to have to zoom out here a bit. Zoom. Yeah, okay. Let's just put a 2 there. Can I squeeze a 2 in? So now I got 2 C20s. Let's just do another count. See if this works. I got a feeling it will. I hope so. If I put a 2 there, multiply that guy by 2, 30 and a half times 2 is going to be? 30 and a half times 2. 61. 20 times 2 is 40. 21 times 2 is 42. Okay, let's see if this works. I got 2 C20s, which is a total of 40. I got 2 H42s, which is a total of 2 times 42 would be 84. I got, that's 61, right?
Yeah.
61 O2s. That's 62 would be 122, right? 122 O's. Okay, right side. 40 times C. That worked. 40, oh, let's do the H's. 42 times here is 2. 42 times 2 is 84. Oh, I've got a feeling. 40 times O2 is going to be 80 plus 42 is?
Wow, if you would have known this before, why wouldn't you do that?
Here's the part where you say, Mr. Bennett, you're a genius. Thank you, sir. Do you? I don't know.
Then why'd you make us do it the other way?
What other way?
Why'd you do that?
I just showed you what happened. What I did was, is I honest. As honest as I can be, do I have the answer here? I did not know the answer prior to that. I did not know the answer to it, but I realized that everything, if I multiplied this one by 2, what would happen? It'd become a whole number, right? And would multiplying all these by 2 be okay? Yeah. Absolutely, right? I kind of used some math background here. It's kind of like, instead of reducing fractions, doing the opposite. It's kind of what I did there. So there you go. Okay?
So
will I expect you to be able to do a hard one like that? No. I would. But I'm just showing you, when you get stumped, that's the technique that you can use. Okay. Well, but multiplying, right? Make them bigger. You can use a half number. If you had a quarter number, then you'd have to multiply by 4, right? Yes. No, you need to listen. Breaks too rapid. If a candle is lit and placed under glass, what eventually happens?
Candles go out.
Candle goes out. Go ahead. Candle goes out. Go ahead, Chance. Candle goes out.
Where?
Go ahead, just right there, right where it says.
Candle
Candle goes out. Where does the oxygen go? Like we're now on number 2. Where does the oxygen go? Like how come it goes out? How come there's no more oxygen?
Yeah.
It uses it up. Now, what does that exactly mean, John? Because is there still oxygen on the right-hand side?
Yeah.
So it's not like it didn't get destroyed. The oxygen didn't disappear. What actually happened?
It got used up at the point.
It got used up, but then where did it go?
Into the.
Well, it goes in the atmosphere in the form of carbon dioxide and water. So where does the oxygen go? It recombines. That's the word you're going to use. It recombines with carbon and hydrogen to form another substance. It's not technically used up, it's just what happens. It's just kind of changed into a different form.
It recombines.
It recombines. It's changed into a different form, exactly. What's formed on the glass? The first time round, we didn't get very much. The second time round with the cold glass, we got a lot more.
Condensation.
Condensation. What is that condensation?
Water.
It's the water vapor, right? And the water vapor, because it's a gas, water in the form of a gas is hot. When it touches the cool glass, which I know is in the fridge, which is why the glass is cold, because it was in the fridge. When it touches the cold glass, that cools the water vapor, which turns it into a liquid. Turns it into a liquid. That's what condensation is. What happens if the glass was cooled prior to being placed on the candle? If the glass is cooler, if the glass is cooled, it produces what?
Condensation.
More condensation. Produces even more. I'm expecting that when we get the glass back from the freezer, we're going to get even more. Even more cold. Thank you, Chance. Yes. You're a fridge genius. Okay. Flip the page over. Now take out your phones or go get a laptop.
What are we going to do?
You got 4 questions on the back. Use your phone or a laptop. Go. Incomplete combustion will occur when there's not enough oxygen to allow the fuel to react completely to produce carbon dioxide and water. It also happens when the combustion is quenched by a heat sink, such as a solid surface or a flame trap. For most fuels, such as diesel, coal, or wood, pyrolysis occurs before combustion. In incomplete combustion, products of pyrolysis remain unburnt and contaminate the smoke with noxious particulate matter and gases, also known as, Chance? Rolling coal, apparently. I learned something new today. I didn't know that. Which
Search
is,
it up. Search it up.
I'm afraid to.
No, it's good.
It's good?
Yeah. If you ever looked at a semi
Yeah?
well, it's accelerated.
Rolling coal. Oh, yeah. See, term used to describe when a diesel engine is blowing a thick cloud of black smoke.
You don't want to look at your bunch.
No, I don't want to look any
Not
further.
Urban Dictionary.
Yeah.
Everybody swears.
Yeah.
Videos.
Too
much stuff. Yeah.
So, what's happening when the rolling coal is happening? Not enough oxygen, right? Which is what happens during coal. A chance? Why is that? Because what are your carburetor? Because I'm not a car guy. I don't know. Unburned diesel. Can they not recycle some of that the unburned diesel?
You just put a pail there and you collect it all.
Really? That's all you do? Just put a pail. Maybe siphon it out of the smoke and just spit it back in the tank?
Yeah.
Genius.
Watch a video and roll it forward.
Nah. I'm afraid.
Just give me some now.
Well, kind of what I just said.
It's perfectly fine. There's nothing bad on rolling coal.
Yeah.
Just do
It means that there's the gas is not burned, the fuel is not burned completely, and you actually get gas particles and other matter that's not. You don't actually get good gas mileage either, do you? Right? Why not?
Are we handing this? Maybe you should chip it out or something.
Why don't you get good gas mileage, guys?
Chip it out for gas mileage.
Because you're wasting fuel. You're not getting the energy out of that fuel. Exactly.
That's why you chip it out.
I don't know what that means.
It's just
Waste fuel, basically. Yeah. Okay. Why do natural gas furnaces in people's homes need a supply of fresh air?
So you can keep the flame burning.
Like,
because the carbon dioxide is reburned producing carbon monoxide.
Which kills you. It's a silent killer.
It is carbon monoxide, the second color, right? There is oxygen in your home. Ladies, are you still looking stuff up or what? Yeah, okay. There's oxygen in your home that combines with the natural gas to produce the heat, right? But if your windows are all sealed up and your doors are all sealed up, it's just like being in a glass like that, right? Eventually the oxygen's going to do what? Run out, right? There's not going to be enough oxygen, and you're going to get incomplete combustion. Your furnace might die. You would likely die before that.
That's why you have those little no, sensor.
Yeah, it's like carbon monoxide.
It was the link, I don't know.
I think you're not going to have to have challenge.
Like natural gas alarms.
Number part C. Explain why when starting a fire, some people may gently blow air onto the kindling. Why does it help? If you're trying to get a fire going, why does that help?
Constant flow of fresh air helps the sparks or flames.
Okay, so you're providing more what?
Air.
Oxygen. I thought when you breathed out,
You're blowing.
you're actually exhaling carbon dioxide, not oxygen.
But you're blowing.
There's a little bit of oxygen.
There's actually quite a bit of oxygen in your breath that you exhale. There's quite a bit. And you're providing fresh air. And you're also doing what to the carbon dioxide that's produced near the flame? You're blowing it away. So you're basically supplying fresh air. But then how come, what about when you blow candles out on a birthday cake? How come you just don't get more flames?
Because you're blowing the heat away.
You're blowing the heat away, really?
You blow the heat away.
Yeah, you don't
Is
want
that what it said?
Yeah, then they can generate fire.
You're actually right. You're actually creating a wind chill effect. You're blowing the heat away, and there's not enough heat to burn, to keep the flame going. Exactly. Okay. So there's a law of sort of diminishing returns, right? When you blow air onto the fire, you provide it with some more oxygen to get it going. But if you get too much, then it actually blows the heat away. I'm going to see if we can do that.
What?
Have you ever seen a flame blown out in slow mo?
Yeah.
You guys look it up.
Don't worry, tell my dad no problem.
What?
How old are you?
Me? Asking for my age? Oh,
You better have a birthday song. How much?
No.
Yes.
yeah, I think my dad's gonna kill us all the next month.
I hate to throw a party because like I'd be so weird that would show up.
I would come.
No, you wouldn't.
Why not?
Every party I go to, right?
Yeah, I was like, I wouldn't even
Guys,
invite
when I
you.
turned 16, even though it's not my like school days, I get trouble. They just
Can I come?
in country fest, everybody was going to country fest, and all my friends so
Yeah, right. Sure. Yeah, I forgot.
Yeah, he had 2 beers.
Yeah, oh,
No, I don't know where I live.
Hello, Liam. So we've discovered that our latest dog has now learned how to jump over the fence because we got so much snow in the background, or in the backyard. So now big.